The only reason why we have EMF, back EMF, is because the voltage is going in one direction. And that's what's causing the back EMF, not the current. The current suffers because the voltage creates resistance. See, I learned a long time ago in playing around with simulated circuits that resistance may impede voltage, but it works both ways. It's a bidirectional relationship. Voltage can create resistance. Now, how can we put this to good use? To eliminate back EMF. How? By not by cross-winding a coil, maybe, but not in this instance. We create something that kind of resembles a transistor, but doesn't really behave like one. All right, so I've modified. It's good that I received your criticisms, thank you, and that you gave them. You know, why a fluid? A baking soda borax fluid for a transistor doesn't make any sense. Okay, so I substituted in a dielectric electret medium, which I now call a dielectret, according to Mark McKay's analysis of the recipe that was very popular 100 years ago. The general recipe that everybody had variations on, and Tesla had his own version, which was 5% carnauba wax, and the balance was 50% pine rosin, 50% beeswax. Now that has both dielectric properties and electret properties. Okay, so we create a 3-terminal component, and one of the leads going into it, or approaching, shall we say, approaching the component. One of our connections approaching the component is aluminum wire, and the other two are either iron or copper. Now, the aluminum does not enter into the component. It is connected to an aluminum plate on the outside. Meanwhile, either the 2 iron connections or the 2 copper connections, in either case, they become electrode leads that go into the component inside of it. So they pass through a dielectric vessel, or dielectret if you prefer, maybe, inside of which is a hydrogel, I'm guessing. Now that's speculation. In as much as I have to go back to the fluid concept, but maybe not borax baking soda, because now I've excluded aluminum from the equation, so it doesn't have to be borax baking soda. It can be something else. And then I thought of, well, how about salt? No, you're going to create hydrogen gas, and that's no good. You'll get current, but it's no good. So what's the point of the liquid? And then I thought of a hydrogel used in certain battery chemistries, such as nickel cadmium or nickel metal hydride. Well, let's stick with nickel metal hydride. Now, I don't know the properties of hydrogel. I'm just thinking there has to be now a subdivision between these 3 electrical connections, one of which is not a connection per se, the aluminum, because, well, no, it is, but it's not. It does not pass current. It's designed merely to apply voltage. Why? Here's the kicker. Because voltage will increase resistance. Now, why do we want that? Well, the iron coil is going to remember, in between any kind of surge, when there's a lull nearby the median of the oscilloscope tracing, you know, it's neither too positive or too negative, there's going to, what we're going to see, if we had X-ray vision or whatever, we had a computer or simulator for a brain, we would see remnants as about the only thing left remaining in the iron barrel-shaped coil, because that iron is like a PMH experiment, a perpetual motion holder experiment. We have remnants in the coil. And having voltage, and then in the copper, we're going to have no memory, no magnetic memory, and that helps to amplify reactance, electrical reactance. So we get more extreme voltage reactances or more extreme spikes of voltage resulting from the application of voltage. So we accentuate the voltage response. But regardless of how copper behaves contrary to iron, when we use aluminum applying a voltage pressure to a voltage spike or an increase of voltage to the exterior vessel of this component, which contains something conductive on the inside. I'm just speculating a guess of hydrogel, whatever that means. What happens is when the current wants to pass from one iron lead to the other, or from one copper lead to the other, or electrode if you prefer to call them, because they're entering into the conductive medium, supposedly hydrogel for the purposes of this discussion. Let's just posit that possibility. We are increasing resistance in that hydrogel. Now, what does that mean? Well, instead of getting back EMF, we don't get back EMF. We reduce it. We reduce the back EMF significantly, hopefully, so that it doesn't compete with the current. Because remember, back EMF is a reverse application of what? Resistance. But caused by what? We keep saying it's current, but it's really reactive voltage resulting from various impedances, in this case inductive impedance, within a framework of time. So what I'm guessing now is that we accentuate the peaks of whatever is oscillating, and we de-emphasize the naders. We de-emphasize the naders so that we get more extreme spikes or surges, and we want that. In fact, we want it to keep increasing, and that's what's going to happen. It's going to it's going to have an accelerative effect, or accumulative. It's going to have an accumulative amplification up to a certain limit. I don't know, based on the design of the thing. Like how much inductance on the iron coil, for instance, how much capacitance on the Leyden jar or / capacitor that's on the copper side. Because that's going to matter. Those two things are going to help regulate the capacity for the two forces, the dielectric force and the magnetic force. Let's leave it at that. I'm not very good with electromotive and magnetomotive, although electromotive is the dielectric and the magnetomotive is the magnetic. Okay, whatever. So we already have names for those forces, whatever. Don't have to make up new ones or transfer Eric dollars over. In any case, we're accentuating. So it becomes, okay. So I think that's what's happening. Why? Because I'm wondering what kind of gating effect, because that's the whole point of a transistor. Normally or a vacuum, especially a vacuum tube, you have the base, it has usually like a screen in between the collector and the emitter inside the vacuum tube. So we're not doing that here, are we? Right. It's a little different. A little different theology here. Conceptualizations. So now we're simply increasing voltage in a periodic manner, random or regulated, to increase resistance of the conductivity between the two iron electrodes leads or the two copper electrode leads, going through some kind of conductive medium. I'm assuming for the purposes of discussion, why not posit the possibility of a hydrogel. Now I thought, well, as soon as I thought of hydrogel, at first I thought, well, that sounds like a battery. Well, it is. But it's got, let's see if I get this right, 2 anodes and 1 cathode. The cathode being the aluminum and the anode being either the copper or the iron leads, pair of leads. And that's useful. That's nothing wrong with that. So we got a battery. So the Ammann brothers lied. Oh boy. They said there was no battery. Without batteries. Well, but they put 2 batteries in there. But they're dynamic batteries. They're transistor batteries. Wrap your mind around that concept. it's a kind of a blend between battery chemistry and transistor chemistry, or transistor dynamics, I should say, because we still have the gating effect of the aluminum lead. Applying voltage, increasing resistance, reducing current. Wait a second. No, I may have this backwards. Maybe it's increasing back EMF. Why would that be useful? To build up voltage, of course. And then it's left to the responsibility of the iron coil to remember the current in the format of a magnetic field. Right. Because you have to wonder what's going on. Well, what's going on in a PMH experiment is the remembrance of the magnetism inside the iron, or is it the field associated with the iron in the PMH experiment? It might make a difference. Because copper may want to centralize that magnetic field into itself as current. See, now that makes sense. That's why God gave copper 6 times less resistance than iron, because the iron is remembering the magnetic field. But see, now aluminum would do that outside itself, so that doesn't make any sense. But it wouldn't remember it either. Oh, of course not, because it expels it. Why should it remember it? So now we have to... Oh my God, this is disgusting. Oh, this sounds bizarre. I'm going to have to say it, though. Both iron and copper exhibit a dynamic flow inside themselves, except for the fact that with the case of copper, it's current, and with the case of iron, it's magnetism. But it's both internalized, and that's why... Well, oh, I see. Because the paramagnetism of aluminum expels it, and so it loses control, so there's no memory. But iron internalizes, but it's still a magnetic field in the space between the iron particles. That's why nobody bothers to insulate the iron wire, because they don't need to, because it's not current. It's magnetic field, but it's inside the iron wire in the spaces between the iron atoms. Okay? So that makes sense. Meanwhile, the current is a change of state of voltage, a dynamic state of changing voltage, engaging the valence shell electron orbitals of the copper atoms that are linked together as copper wire, or copper tubing, or as the case may be. So it's different dynamics to create an equivalent reality, but because it's different dynamics, it's different behavior. So the iron remembers, while the copper accentuates the surges. But now if we create this hydrogel-style transistor, oh boy, that increases resistance, and everything is locked together, synchronized, we're actually increasing back EMF. Why would that be useful? See it. I wanted to say in the beginning a reduction of back EMF, but because I was assuming that because it goes in reverse, it goes on every half cycle, the subsequent half cycle, rather than the applied cycle, the resulting half cycle, the reactive half cycle. And actually that's true. I think. Not really, though. Because back EMF wouldn't be able to fight the application of voltage if it did not go in reverse. But that's in a copper coil. Well, whatever. In any case. No, it sounds like This is actually accentuating back EMF. I'm sorry. But why would we want to do that? Well, to increase voltage on the copper side. Duh. And, I see what I would see. Now, this is what I was, I knew there was a reason why I said that. Okay. The way it's set up, there's no distinction between collector versus emitter. And that means two flows are happening simultaneously going in opposite directions. Remember, Edward Leach Scollin said that. He claimed current is a monopole, and it always goes in opposing directions simultaneously. The north polar one goes in one direction and the south polar goes in the opposite direction. But what if we create a circuit dynamic in which we have two north poles on every half cycle going in opposite directions and then two south poles going in opposite directions? We get a cancellation of current, don't we? And current is the resulting volt. Well, oh boy. That means that if voltage is cyclic, it alternates polarity every half cycle, but the current does not, because the current is always going in both directions per half cycle, even though each, if we labeled names on each of the two north, let's say the north pole, monopole, objects of energy, of magnetism, to distinguish them, and they swap places still, they're twins. So it doesn't really matter for all intents and purposes. But so we're going to get both. That's it. Okay. Finally, I'm sorry, I'm groping here. We're going to get an accentuation of back EMF per half cycle and then a diminishment of back EMF per half cycle. So we get this extreme back EMF per half cycle, and then, let's say next to nothing on subsequent half cycles. And that means that we're going to get a dynamic that's going to accentuate voltage per half cycle and accentuate current per half cycle. And this, I'm limited with simulated circuits. I can only do so much. So with your help, I'm able now to figure this out in my head. Not to say I have a simulator for a brain like Nikola Tesla, but just by logical conclusion, I'm thinking my way through this. So in the past, what I would do is I'd use a technique in which I would have a kind of a step-down transformer situation. But because it's being generated within the circuit, it's the same as if it were electrically shorted between the two sides of the transformer, because it's magnetically coupled between the two coils of the transformation. And usually it's not two coils on either side, it's a minimum of a pair of coils on either side of the transformer. And ideally a third coil that's magnetically coupled to the two pairs. And in that case, when it's step down, step up, you get an accentuation of voltage on one side and an accentuation of current on the other side, and you change your gauge. The wire you use a wire gauge that encourages resistance on the voltage side, the upside of let's say the step-up transformer, and then you use a much wider girth, a lower wire gauge number on the side that accentuates current over voltage. And because they're magnetically coupled, you get a nice amplification of watts, because we're not applying power to this transformer on one side and then getting it transferred. We're empowering this coupling of two pairs of coils to generate power from within itself, because we've also managed to get amps and volts to segregate themselves from each other by a whole half cycle, causing the whole thing to become a generator. But this is a different way of doing that. Instead of demographically segregating voltage in one area of a circuit and current in another, we're segregating it in time, so that it appears, though, everywhere. So there's no area that it is being segregated, but it's then it's replaced by its opposite force, ingredient of electricity, accentuated over time in a dynamic or alternating manner. So instead of saying AC power, this is something else. This is something else, because it's not merely an alternation of polarity of applied voltage, getting again a polarization of back EMF when you transmit down the length of a transmission line. Now we're getting this confusion of status, because insofar as current is concerned. So it's not alternating current so much as it's the alternation of back EMF. So half the time, half the cycle, it's competing with you, and half the time it's helping you. And by getting this accentuation, we're now accentuating current and voltage per half cycle everywhere in the circuit, rather than segregated demographically. And this is a very interesting concept. I never thought of time being a way of segregating current from voltage dominating the circuit, because you have to do that in order to manipulate those two forces. We can't separate them. Ohm's law, they're squeezed together by multiplication. And this always bothered me 30 years ago when I first tried to take 101 electricity in community college, and I couldn't stand the fact that amps is times volts, making it a singularity. When we don't treat them as such, we treat them as two different entities that we measure separately with two different devices. Why aren't they summed? Why are they multiplied against each other, making them a singularity? This doesn't make any sense. Well, in nature, they are individual singularities that make up the ingredients of electricity, but in order to have electricity, they have to be bonded to each other in such a manner that we see them as manifest as a singular force, which is the daughter of the two parents. And the daughter of electricity does not exist unless the electromotive and the magnetomotive forces are combined and in phase, blah, blah, blah. But we're playing with this now so that we get back EMF. We get not the alternation of current, but the alternation of back EMF. That is bizarre. And meanwhile, current's going in both directions per half cycle in equal quantity, which you would think is useless, but not when you're changing your impedance every half cycle. So it's not the alternation of current, it's the alternation of inductive impedance. Oh, how do you like that one? So instead of AC power, we've got, what is that? AII. Oh, this is good. Instead of dumb robots that Will Smith and iRobots couldn't trust them as far as he could chuck them, now we've got I squared, shall we say, or I sub 2, or 2I, A2I. Yeah, let's call it A2I. Let's not... well, no, everything in Ohm's law is multiplied, so... okay, I squared. So we got AI squared, alternating... hyperbolic impedance because it's accentuated. So it might be a geometric accentuation as opposed to arithmetic. See, now this I wouldn't know. What happens when you do something like this? Is the accentuation multiplicative or is it additive? That's something only somebody who tests this out could figure out. But now the theory behind it makes sense because of the modification based on your criticisms. Thank you so much for your criticisms. I wouldn't have been able to do this without you because I don't have any formal training. All I got is intuition and the desire to get involved to help out. That's it. And the time I've spent training myself to the extent that I have. But, you know, you can only go so far when you raise yourself up by your own bootstraps instead of somebody helping you out. So whoever is feeding me this knowledge is only one contributor. Your criticisms mean you are now the contributors, and you have as much to blame or take the credit, depending on how you want to look at it, because we could be destroying the economy for what we're doing. We're such rebels, domestic terrorists, creating a whole new way of living together, a society that can't use money anymore because we can't charge for energy, blah blah blah. Energy has to be, the power station has to be built into every appliance, and so you get energy for free for the lifetime of that appliance, basically, until it needs repair or replacement. It's the way I look at it from a political socio-economic standpoint. This kind of free energy technology means that, and that's the way they did it in Atlantis. They had a socialistic government. It wasn't what we have. It was socialistic. Yeah, everybody got housing and heating and lighting and cooling transmitted optically, I think over fiber optics, for free. It was allocated to you. All you had to do is pick what job you want to work at. You didn't get paid for working. It was just considered your duty to work, And that's the way I look at my contributions, because I never had to work until recently, and so I felt, okay, public service, voluntary service is the way to pay back society. So I started with tree people and the LA Philharmonic docent and the Hollywood Bowl become a docent. And then I just went to the internet and said, hey, I can stick to the internet and pick and choose my voluntary service. I don't have to be under anybody else's authority anymore. But that means I'm isolated from everyone to some degree, because I'm not sure how to go about learning. So I would learn. I would examine and witness what other people did. I'd look at their software code, how they did their JavaScript, their Perl script, and whatnot, and try to apply it to my situation and make modifications thereby. But in this case, it's a little bit harder to do something like that, because we don't have free energy examples. It's all been repressed, so I can't study working examples. So to get any idea, I just have to do like Edison, the hard way, to get my training, to think sort of like a simulator thinks, and then get theory from the internet to make up the difference so that I can modify in my head how electricity would work in a circuit simulated in my head. But I still need help from you guys, as well as whoever is feeding me. Archetypes mainly. They're kind of like generic, schemes there in which the details are not mapped out, and so I still have to grope for those details with your help. And I guess that's why Aaron Murakami, it was fortuitous that he do what he did and publish what he did when he did, because I had already started to receive some images or whatever thought concepts, and that was my cue to get involved with his contribution, that thread, so that I could engage your criticisms, and they're very valid and they're very useful. So it's kind of like a transistor, kind of like a hydrogel battery, kind of like a capacitor, kind of like a diode, a borax baking soda diode. So now I'm not so sure the aluminum is preconditioned, whether or not it needs to be, because it's flanked, or it has to pass through a dielectric or a dielectret material, as the case may be, before the other two leads receive that impetus coming from the aluminum side of that three-ring circuit, what I called a transistor. So it's not really a conventional transistor. It's a custom-made transistor. Right, exactly. It's a customized transistor, customized for the purposes of accentuating the alternation of back EMF. How do you like that? A new form of power resulting from the alternation of back EMF. There you go.